Thank you for the invite. I love it. I'm so excited to be here to talk to y'all. Soil Summit 2000, what is it, 2024? The nature of my presentation is going to be about soil, but I wanted to give you a little bit of a backstory about myself. I, like Greg, am also a Back to Eden grower. I've been a Back to Eden grower for the past 14 years. I tilled my last earth 16 years ago. If that gives you a good idea of things. So over the past 16 years, we've converted quite a bit of my land. I own 10.5 acres in the Piedmont of North Carolina. And our goal was to go from the dead land and the dead earth that we had inherited to, well, a much more Back to Eden style growing environment where all of life is essentially welcomed into it, where the killing is stopped. So I want to give you all a brief idea of who my influences are as well, because that's kind of important for you to understand exactly where I'm coming from, as well as learning an immense amount of things about the principles of growing food organically from the master himself, Paul Gauci. I also learned quite a bit about mycology, so it's great to hear that section on mycology before. I love it. Great work, Kevin. On Paul Stamets, another one of the big influences. Love his stuff, love learning from him, love his insight on white rot fungus. And it was awesome to come out here and see that be actually part of the subject of the first discussion. So, yes, these guys are all influencers for me. But another big influencer for me was none other than Dr. Elaine Ingham of the Soil Food Web. And it was her teachings, her instruction, where I learned how to do the soil biological examinations, where it can be said that we don't know what's going on in the soil. We don't know if we don't look. So those skills, having access to a small laboratory in my farm, pretty much 24/7, they afford me the ability to look at sort of a micro level and a microcosm of things, the small order of things, at what type of life is actually living in the soil. And as it turns out, this soil life is highly instrumental in keeping things going. And as you all know, I got a pretty good impression that we've got a wide variety of growers with different skills amongst us today. From I just started gardening to I've been gardening for 20 plus years. And that's great because today's presentation is probably, I'm going to share some things with some of you that you might have never heard before. And I'm going to share some things with some of you that you may have heard before. We're going to take a walk around. I'm going to take you to my compost station where I've operationalized the process of making soils and composts, utilizing things that we essentially grow right here on the farm. And the idea behind this is that I want to utilize what I have here as much as I can and avoid as much commercially obtained amendments and chemicals or soils or really anything for that matter. The goal in permaculture is to essentially put your own environment back to work for the environment. And that's what we attempt to do here. But the way I've operationalized it, I have an area for composting aerobically. Okay, and this should sound like it makes sense. I also have a small area for composting anaerobically, which may be coming into view. I'm going to talk about that. Before you all leave today, you're going to learn how to make free fertilizer. I have another area where I actually make machine-based compost, which is probably what most of you are familiar with seeing. And then another area where we make more nature-inspired wood chip compost. And that area is actually closest to the main gardens. So this viewing right here should give you a pretty good idea of how my layout is spread out over approximately 1 acre worth of land. I can give you a little backstory here to this land. This 1 acre, we used to grow all our food here. 15 to 20 years ago, we tilled this land and we grew with salt-based fertilizers, and we used insecticides and fungicides and you name it, whatever it was. If it said sides on it, we used it to try to get our crops to grow, and we failed miserably over and over. It's amazing how hard I felt like I was working only to fail. What I'm going to show you now is how switching to the organic methods, more organic methods, has changed things. And if at the end of the 35 minutes, I got a timer right here, we still have time, I'll show you all what the green vigorous growth looks like. For now, let's go look at soil. It should be said that every grower is going to need sufficient soil to cover the requirements of the roots of their plants. There are very few plants out there that grow without soil. And the vast majority of plants that we're going to grow, they want living soil. So here before you, you can see one of my composting zones. This is an aerobic composting zone. We concentrate our efforts on keeping things aerobic and keeping things thermophilic, keeping things oxygenated, keeping them from getting too wet, keeping them from getting too dry. All of these things are necessary in a proper composting operation. I can describe the operation pretty simply put. This is our resources. It comes in like this. I bring it in when I cut grasses. I cycle cut my pastures. I never cut all of my pasture grasses down, especially in the growing season, because that reduces the amount of habitat, that reduces the amount of food supply, moisture supply to the insects that live in my habitat. The insects that visit my gardens, if they visit my gardens hungry, they're probably going to feed on my plants. But if there are other food sources that are in the area local to my gardens, like we have now, they tend to stop there and graze. And those pastures that we used to cut, we're saving money on because we don't invest in the gas or the diesel to cut them anymore. Now the grasses just grow up, and the animals have returned. The deer have returned. The rabbits have returned. The fox has returned. All the predatory species have returned. In addition to those hungry insects, the predatory species for the insects have returned. So a balance is essentially coming in. This right here is a magnet for a different kind of balance. This is a magnet for a microbial balance, in which all of the features that they want in their environment, the carbons and the nitrogens and the minerals and everything else, are essentially consolidated here. We have grasses that I cut. We have leftover veggies and leftover eggshells and things that we've taken from foods that we prepared, things that didn't get eaten. And we've got wood chips. We've got other forms of carbon, other things that came that got cycled from the gardens, got cycled from the vineyards, got cycled from anywhere where we have green organic plants growing. It ends up here in this area. These things get chopped up. Behind me to my right, I've got two 250 gallon 4 foot by 4 foot compost rings. It's just simple deer fencing. It's very inexpensive to put these things together, and it lasts a really long time, and you can generate an enormous amount of not just compost, folks, because this is more than compost. It might not look like much compost at this point, but I promise you, by the time it gets to this point where it's been composted, it's been reduced, it's been consolidated, and it's had a lot of the local soil biology added to it horizontally. And talk a little bit about finding some of these species in their niches. I've got wetlands, I've got lowlands and the highlands, and I've got dry lands and everything in between. And that's the funny thing about North Carolina. We can be in drought for 3, 4 months out of the year, and then we'll get wet for a month, and then we'll be drought, and then we'll be freezing cold, and then it'll be very, very hot. The temperature changes, the climatology fluctuates so violently that it's absolutely necessary for me to take full advantage of the biological influence that's successful in my areas of grow and my areas of influence, that's successful in growing under periods of great stress. Who does this? Bacteria, fungi, protozoas, nematodes, microarthropods, all of these soil dwellers find a way to survive. And 14 years ago, when I put the first batch of wood chips on the ground, it didn't take me very long to realize that it was building soil mass, it was building soil biomass, it was building carbon layers, it was building layers of detritus that was actually so attractive to the insects. But building fertility, it really didn't start happening until we started putting plants in. It's that life. It's sowing that life to the soil that begets more life and further life. All of the other things in the soil became interested because of the antagonistic behavior of the plants that we grow. They're dumping sugars into the soils that attract biology. That biology comes and then it senses exactly what those plants need. It gives those plants an opportunity to gain access to nutrients that are maybe further away. Plants can't just pick up and move. The soil over there may be more fertile than the soil over there, but this is the place the plant got planted. So instead, it's going to communicate with the soil biology at its feet. And in doing so, soil biology can work in very special and enhanced ways to improve plant immunity, to improve resistance to drought, to improve resistance to cold. The rhizophagy cycle, maybe that's something new that you're hearing of, but it's something new that we know about now. We know that we can see bacteria entering tiny root hairs inside the tiny little vestiges of the roots where almost your eyes can't even see without a microscope. We know these things are being pulled into plants. We know it now. We know the bacteria is attracted because of the carbohydrates. It's the same thing that attracts the fungi that we were learning about in the previous presentation. So there's a lot of symbiosis going on. There's a lot of mutualism going on at the feet of our plants and at the feet of our own feet that we're not really always aware of. And what I want to say and what I want to press upon everybody is that the vast majority of this stuff starts right here in compost. Okay? I have certain other areas where I can take soil biology from. We talk about not knowing where to find root fungi, but I can tell you where I find root fungi on annular or successional grasses in my pastures. During periods of moistness where there's a lot of rain, I can go down to some of these low-lying areas and pull grasses up, and I'll find root fungi attached to the roots of those grasses. That stuff can enter my composting system. There will be spores with it. That stuff can enter my composting rings. There will be spores within it. And as long as I make a relatively decent ratio of these things and I don't allow it to get too hot or don't allow it to get anaerobic, many of those species, as was detailed prior to this, will actually survive and convey. And many of those species, while they do need roots to attach to grow, they're still dropping spores. Even in this process, my temperatures are only reaching 138 degrees. And even that's for a short period of time. It's not enough to sterilize those things. It really isn't. These compost piles right here, this one right here has already been turned over once. Basically, all I did was I removed the fence from around it and I moved the fence over 4 feet, rebuilt it, and then threw everything on the top of it into the bottom of it, and it's going another round. It doesn't take that long, folks, especially when you have these extra added biological enhancements like the fungi and the bacteria. I can look all around here and all I see is grasses. This area is bacteria dominant. But as we shift and move towards the gardens, the ratio of bacteria to fungi changes. On the whole, it becomes more closer to even, okay? And it becomes closer to even because I'm able to add and inoculate fungal species to the next 2 processes that you're going to see in a few minutes. I can actually inoculate my wood chip piles at certain times with local species of fungi and build fungal biomass. There's already bacterial biomass. But I'm going to show you right now here. One of the most common mistakes people make is not having a composting thermometer. These things, they range anywhere from about $12 to $25 for one that's pretty good, one that you can read, one that's not in Celsius for the US. They last almost the lifetime of the grower unless you get it caught up in the tractor or the lawnmower. But these are great because if you see the temperature start to approach 150 degrees, bad things happen. The compost will start to denature, and it almost gets to the point where the compost will be toxic. So when Creedmoor says, hey, don't let your compost get too hot, don't let it get too hot. What can we do about cooling it off? It's a cool off compost pile. You can always either make small holes in it with the end of the handle on a rake. This is called stovepiping. And even after only a split second, this is warmed. You can add carbon matter to it, more wood chips, more dried leaves, aged leaves, and that will tend to cool it down. I typically don't pour water on it to cool it down because that can make it more anaerobic and that brings on other problems. But I want to show you all what it looks like here. I'm going to pull some finished compost from this pail, and y'all are going to get an opportunity to see what happens after this has been sifted. Hopefully there's enough sunlight and I can hold it steady enough. I'm not sure, maybe I can get into the light a little bit better, but you can see it's very, very broken down. There's actually a worm right there. I'm not sure. Anyway, it's full of life. One of the things that makes this process work so much better for me is that I can take a small portion of this. I can put it on a slide and I can look at it under a microscope. And I can essentially examine how much of the functional soil biology in life is present. I can examine and determine whether or not there's predatory species that will consume fungi and will consume bacteria, and whether or not there's enough of a cycle of the food web existing in place, or do I need to go out back into my local environment and entertain the thought of adding something else from somewhere else? Okay, so I'm going to show you over here something else that's really interesting. So talked about how to make compost. We talked about how to make it biologically enhanced. Now I want to talk about a way to save serious amounts of coin. On the other side of the aerobic spectrum, there's the anaerobic spectrum. Inside these barrels right here, I make fertilizer. Okay, camera person's going to show you what it looks like inside. This is a example of anaerobic decomposition. And in this particular case, this stuff is fermenting down into a liquid fertilizer. It takes about 4 months for this to happen, for it to really get to a point where it's of any value. And what I do is I actually fill this particular 65-gallon drum from bottom all the way up to just past 50%. I use well water or rainwater to fill it up from there. It starts to decompose immediately. I think we were talking about rice inoculants. Sometimes I'll use a rice inoculant. We'll put cooked rice in here. We'll put cooked potato in here. I like to use lactic acid bacteria also. They work really well in this. And this particular fertilizer, this lasts me. I grow on over 8,000 square feet of back-to-Eden type gardens and beds. And this particular fertilizer has replaced all types of fertilizers that we used to pay for. Anything I used to go to the store for, the blood meals, you name it, it's all been replaced by this. The only other type of a fertilizer that I ever use, which again, I use it as a biostimulant, is called fish hydrolysate. I understand that Greg likes to use a fish emulsion, which is another good quality product, but I make the fish hydrolysate myself by catching fish from my own pond and grinding up the fish and then turning it into a fertilizer. Something we can get into another time. But this right here is a great way to stop from having to actually purchase your own fertilizers. I make it utilizing everything I grow in the garden. And if you're a new grower, you're probably going to grow some crummy plants that are going to die. They're going to wither and die. It takes some time to sort of get your bearings. So you have plenty to make in your first year. If you're an old grower, you've got plenty growing already, and you know some of your plants will cycle out. When they cycle out, we bring them here. At the end of the season, they cycle out again. Even more biomass comes from my gardens. And that's how we process here and here. We're going to go over here and talk about this. And folks, if y'all think I'm doing this in a hurried nature, it is because my trusted timer is telling me that time flies. This right here, this is the machine-made compost pile where the vast majority of this is, I should say 60% of this is 6 of 10 payload of bucket scoops, however you want to look at it, 6 of 10 5-gallon pails, 6 of 10, this is the ratio, are going to be raw wood chips that we collect. We'll get to that stage next. The other 4 scoops are going to be high nitrogen rich matter. They're going to be grasses that we finalize when we cut at the end of the seasons. I'll collect all of the grasses from the pastures. I'll have a pile that's this high. Then I'll take essentially 4 parts of those grasses and manures, mix them with the 6 parts of the wood chips. This pile was twice the size 3 months ago, but it's been reduced to 50% its original size. It's also composted quite a bit. And the further down we get to the end of it, the closer we get to last year's compost. And when we get to the most composted materials here, this is the best part of this, because y'all are always looking for, well, every gardener is always looking for more soils at the beginning of the year to plant in. I'm going to show you what we do. It's so simple. It's so easy. This is something that I learned from the master Paul Gauci himself. We built a simple sifter box that's 2 foot by 2 foot. It contains 2 wire mesh screens. One of them is a 1/2 inch hardware cloth. The other one is a 1/4 inch hardware cloth. When I want to make soils that work for germinating seeds, I use the 1/4 inch. When I want to make soil to cover certain species of plants to deepen them, like some potatoes, to bury things deeper, I'll use the 1/2 inch. If I want to establish a different type of a bed where the soil constitution doesn't have to be fine, I'll use the 1/2 inch. If I want to establish a bed where the soil constitution has to be fine, like as in for certain root crops like carrots, we're going to use the 1/4 inch fine screening. So again, if I'm going to germinate, we're going to use a 1/4 inch screen. All I do is place it on the top of this and come to either my oldest compost piles for standard compost and standard soil, or the next stage, I have 1-year-old wood chips. And we were definitely going to get to the wood chips at some point. And we're actually going to see the difference between 1-year-old wood chips, 1-month-old wood chips, and 3-week-old wood chips. So, oh, y'all want to see me get dirty? Y'all want to see me sift through a bunch of this? No, the camera person is shaking their head. No, we don't. It just goes like this. We put a scoop of it in here, you wobble it back and forth, and in about 15 minutes, the whole entire pail is filled. When you start out with old age wood chips or old age compost or anything that's of the finer grained and it's been maturing longer, this pail fills up faster. So we should be clear on that. If you try to sieve a wood chip that fell off the back of the truck yesterday, it's not going to work. You already see the constitution of this. You can see that it was organic matter. It's not quite done yet. There's a lot of evidence of the parent media still being in it. That being said, you'd still be able to get some sifted fines out of this, but there's still a better source. So over here, I've got exhibit A, B, and C. It looks like one giant pile, but it's not. It's actually three separate piles. And there's a difference. And this is really, really important if you're going to start to build soil carbon mass and soil biomass, especially if you're going to utilize something like this and not a living cover crop. These particular wood chips have been sitting here for a year. They've been turned probably 3 or 4 times with the tractor over again so that we can start to break down and reduce some of the larger and coarser media into finer media. At which point, you can build a garden with this. Right now, this 1-year-old wood chip pile, you could build a bed with this. Okay, so let's just keep that as a placeholder. This pile of chips right here is significantly lighter, and you can tell just by looking at it. It's lighter in color. It's still very coarse of texture. There isn't very much fine media. This was actually dropped off just a few weeks ago. So it's not really good for growing in fresh wood chips unless you're a tree. Okay? It's different if you're a tree. When trees are standing timber, they contain tannic acids, antibacterials, antifungal compounds. That's what helps them stay up standing as long as they do. The mighty oak has a lot of resistance to disease and predation. When we chop it up into little bits, those chemistries are still held within it. It's hydrophilic, meaning it absorbs moisture. Well, it absorbed all those acids while it was standing timber. And then we cut it up into little pieces and we left it sitting here. Those acids will be reduced quite handily by rains and time, the solar influence as well. So in this case here, as the acids are reduced, they're converted to humic and fulvic acids instead of, still got me? Okay. Instead of the original tannic acids, which are so restrictive to growth. Okay, so here we have higher concentrations of tannic acids, which are really super restrictive to growth unless you're a tree. We got to compromise over here. You see this stuff here? It's a little bit darker. Okay, this stuff right here is actually about 2.5 months old. And whereas this is important to note too, because in the winter, when there's not much weed pressure, I'm trying to do all of the work that gets you hot and sweaty. Y'all know what I'm talking about. I want to do all the hot and sweaty work when it's a little cooler out. So in the fall, on my Back to Eden garden, which is just over here to my left, I'm applying that compost that you saw one step back. Okay. I know I'm enriching it with manures. I know I'm enriching it with the nitrogen from the green grasses and from the leaves that were in the wood chips at the time when it was collected, etc. So that makes a great starting base for my fall amendment. Greg talks about only amending one time in 3 years. We amend every year. I do so much growing. I grow so many different crops that I have to amend. The soil is reduced that fast in North Carolina as well due to our climate. So fall is going to see that compost in one single layer right over the top. If I had any other amends, like something that was like an aged chicken manure, I might put that somewhere specifically, but never would I blanket amend that. It's just too much of a waste. We could do so much more if we take the chicken manure and make a compost with it than we can if we just put it on the ground in one little 4 foot by 4 foot spot. So this particular batch of wood chips right here, it still has some resistance to it, okay? Spring rolls around, my plants are growing in the compost layer in the garden. By the way, my compost layer is really deep. And they're happy and they come up. and then we get rains, and then we get weeds, and the weeds blow in with the wind. And if I was to use this slightly aged, 1 month old wood chip pile as a cover, I'm done weeding. I won't weed for the rest of the year. So now I have my plants installed to the soils. They're growing. My nightshade family, everything is growing. My potatoes, my tomatoes, they're all up. Everything's growing like it is today. And I start to notice that there's an increased pressure from weeds. They're visiting me because they're blowing in from the pastures and they're setting seeds. I don't want to constantly be out there like this. I don't have time for that. Okay. And I'm not going to spray some sort of chemical herbicide. That's not happening because the second we spray an herbicide or an insecticide of any kind, folks, listen to me, listen carefully. It leaves a residual scent in the environment that the predatory species that would have naturally come to your aid will scent and smell and say, hey, it's not safe to be here anymore. We absolutely want a pure and organic environment. And that's one of the reasons why this media works so well, because these are scents that they're familiar with. Compost is a scent that's attractive. And the more of this stuff that we put down into our soils, the more energy the soils have. And the deeper we make our beds, the more habitat there is for the little microbes that take care of our plants. So soil biology is better protected. The erosive forces change. So if you're anywhere where you get heavy rains really, really fast, bacteria and fungi make these glues, and the glues bind soil particles together. And then they mine for pore space to create ways for moisture to move through the soil at a predictable rate. And the most amazing thing that they do is the diversity affords them the ability to work fast or work slow, to be active right now or be active later on down the line when the environmental conditions change. And that's what's so special about having diversity. And that's one of the reasons why we make so many compost teas. So all of this composting just to facilitate the growth in 5 or 6 large gardens. Okay. There's actually extra compost. There's extra wood chips here that I could be giving out and sharing out. But down below us, we have a 20 vine vineyard, and it's grown the same exact way. All we did was we cut the grasses low. And by the way, the grasses were Bermuda grasses. And we piled on 12 to 16 inches of wood chips. So after piling on the 12 to 16 inches of wood chips, I said, uh-oh, I don't have enough wood chips to do this again. I'm getting fused, folks. So what did I do? I'm going to tell you exactly what I did because getting wood chips isn't always easy. And I understand y'all are near a forest in Arizona where there's trees. I looked at the map. Sorry. Anyway, there's a little app on the internet called Nextdoor app, and the Nextdoor app is a way for you to reach out to your community, to other like-minded individuals, and essentially, put your plight out there. Say, hey, I heard about this cool way to grow food. You pile wood chips over the top of the ground, lay some compost in, some soil pockets, and I need wood chips. I don't have wood chips. Does anybody know someone who has wood chips? That's exactly what I did. And immediately 3 people popped up on the app and said, hey, I got them, but you got to come get them. That was great because I went out and I hand shoveled them into my trailer and brought them home. And then my chicken wing right here on the left side was sore for like 6 months. So I knew that was maybe not my best work. But one of those calls was from someone who owned a tree company. And just so happened that he was looking for somewhere to do this. So this is the result of that relationship. Prior to that, the gentleman over my right side here owned a tree company, and now he's no longer with us. So we don't get wood chips from them. But developing these relationships is really, really critical to the success of a grower who wants to maintain a permaculture type of environment. I'm not about to go out there with a chainsaw and start hacking trees down. Most of these trees come to me because either they were a danger to wherever they were planted, or maybe they may have been sick. If they were sick, honestly, I've never had a tree-based pathogen cross over to one of my plants. Truth. I know this because I have some fungal pathogens on some cherry trees that are on my property, and it doesn't cross over to my vegetables. So I think if we've got enough time, we're actually going to take a look. We're going to take a walk. We've got about 10 minutes towards my garden, and y'all get to see what some of the soil looks like.
doing great on time, Creedmoor, so keep it up. We'll do a Q&A
Excellent.
after all this.
Excellent.
We think, guys. Good so far, loving it.
All right, here we go. You got me? Okay. So here in this particular area, y'all can see, it looks like, yes, you're looking right at my fruit and root plot. This particular fruit and root plot is about 8 years old. It wasn't the first thought when I built the garden. I used to think go big or go home, but this was something that we wanted to toy around with and try a few different things. Let's say we were sort of in that experimental phase of being fully organic. And ultimately, this ended up being the fruits of our labor. It's probably difficult to see through the sign. But basically, what you're looking at is 12 inches of wood chips piled right on top of red clay. And then in the first fall, 4 more inches of that compost that you saw. And then in the next spring, 2 to 4 more inches of wood chips. That process has been maintained for 8 years. Anything on the planet will grow here. Anything. Your favorite crops, your most high dollar crops, your cheapest crops, your lettuces, your tomatoes, your potatoes. It's currently home to white and yellow and red potatoes, and also a multitude of different berry crops, because we've got brand new blueberries here. We've got elderberries here. There's even a stand of garlic right slam in the middle of it, and strawberries line it as a border crop. Yeah, folks, I moved the strawberries from over there where the trees are, to over here to sort of foil the squirrels that were getting my second flush. I would always get the first flush, but once they caught wind of what was going on, they would come and clean me out before I can get them. I like to grow the ever-bearing version. So let's come on down here. We're going to move a little bit further. Maybe y'all can see some of these plants. Maybe not. I'm not sure if the picture is grainy. Earlier in the day, there was a whole lot more light here, and it was much easier to see things. As a matter of fact, one of the features that I wanted to show you was the custodianship over the pastures. The pasture where I was standing was full of flowers earlier in the day when the sun was up. And then, of course, once my presentation started, all the flowers closed right off. So either way, not to be too outdone by nature, I'm going to show you all what this soil looks like after it's been sitting around for 14 years. And this is really, really instrumental in knowing there's no dirt in this, folks. This is sort of one of the viewing areas that we like to use when I have sessions here, live sessions here with people. We'll always come here. This is roughly 2 feet deep. And I'm just going to go ahead and pull up some of the coarsest media and reach right into where the roots would grow. And y'all can see that over the course of the years, the soil just gets more and more humusy. I mean, that is just, you still get some coarse chips that mix in there because we step in and out of the beds here and they compress down, and it doesn't hurt anything. I walk on this stuff all the time, every day, for hours at a time, and you can't compress this. You know what the other beautiful thing about the Back to Eden method is? You can't flood a Back to Eden garden. And the older the
one question I have for you, I'm going to interject here. You said very briefly you have no dirt in here. So explain the difference between that. Dirt.
Well, the dirt is what keeps me from sinking to China. It's what we put foundations on. You know, it's very dense, it's very mineral-like, and in my town, it's often rocky. We have a lot of sandstone here interspersed in between the clay deposits. You know, when the erosive forces hit here really, really hard, the top covering of clay will wash off, and you can see the tops of these massive boulders buried all over the fields. It's really quite amazing. Not far from here, a couple of miles from here, there are boulder fields where all of the clay and all of the sand and silt has been washed away, and these massive boulders are just standing there. No doubt from the Ice Age. So, you know, let me expand on that. Your plants don't need dirt. They don't. Mine don't, so if mine don't, yours probably don't. it's not likely that this is some exclusive access or exclusive rights to fertility for Creedmoor Fury that doesn't work for anyone else. Um, and not to mention the fact that I've probably built maybe 50 other gardens that aren't mine that aren't here, and they're all experiencing the same level of fertility that I experience. Some of them, believe it or not, they actually do better than I do. And not a kick in the pants. Right. But in any event, I don't mix the dirt in because dirt is heavy. Wood chips are light. I don't mix the rocks in because rocks are heavy. Greg found that out when they tried to pull all the rocks out of the ground. And all you're seeing here, folks, I'm standing on top of 14 years of putting compost and wood chips alternately on top of the same spot over and over and over again. I'll show you all something even maybe a little bit more amazing. Over my shoulder here, maybe you can see there's 2 greenhouses, 2 tunnels, nightshades, peppers, tomatoes. They grow in there all the time, like all year long. They never stop growing. As it turns out, I learned through the back to Eden method that peppers are perennials. They're not annular plants. So we grow a lot of them. And it looks like my camera person is giving you an opportunity to see inside there. But what I really want to show you, something that's a little bit more amazing because it's the power of microbes. I want to show you how we heat these things. Bacteria is a voracious consumer of nitrogen and carbon. And it's a little bit more difficult to see right now because we already started parsing it down. This pile here used to be up to here, probably another 4 feet higher. And we started with about 35 yards of wood chips and compost. The media that's inside this pile right here is sitting atop 4-inch tubing that circulates air from the inside of each one of these greenhouses into the heated portion of the compost pile and then back into the greenhouses where it's used to improve the temperature in there throughout the winter. The system's actually running right now, but the door is wide open, so it's not holding heat.
What kind of difference in temperature do you get from this when you do that? How much temperature change can you make inside the greenhouse?
Typically on the order of about 25 to 30 degrees. Yeah, what we found is that we can build this a little bit different than we build a regular compost. We can even allow the temperatures to run hotter and go into the thermophilic range where it's like 150 to 165 degrees, and things are starting to get nasty in there. But what's happening is you're bringing the cold air into this, and it's really just a giant capacitor or battery, and the cold air is reducing the temperature as it's being moderated back to warm. So it could be 32 degrees outside, but it'll be 58 degrees inside. And we don't really need a supplemental heat in these because they're very small. And because the climatology in North Carolina, it really only serves us up about 2 weeks of real cold. And for those 2 weeks, I can just kick a little milk house heater in here and everything stays cruising along. So at the end of this process right here, we end up with more cover, we end up with more compost. And the ultimate goal is to end up with an unending amount of these things due to your processes, is to end up with enough carbon cover to protect the soil biology and enlist as much of the soil biology as you can. But remember, not just bacteria and fungi, we also need the predatory species to come and eat them. And, we don't ever want the ratios to be too extreme, too much bacteria or too much fungi because things tend to get wonky. And although I know it's not that common for just regular everyday gardener to own a microscope, in this day and age, you can get a very decent microscope that allows you to see bacteria for under $300. The days of you needing to spend $1,000 to get decent optics, they're gone. They're behind us. A little place called Shinna has seen fit to send us optics that actually work. And some of what's really cool about today's microscopy is you can attach your cell phone. Y'all got a Apple iPhone or a Samsung, there's a little attachment. You put it right over the top of your optical, and now you're viewing whatever you're looking at, your microbe, on a TV screen, because we can also stream to a television, right? So these things are really cool, and we have new ways to share and develop our research. Like, for instance, there's more people out there like me that are very, very interested in the soil biology. Well, we share pictures, we share videos, we share them back and forth to each other. Say, hey, I saw this in my garden the other day. It's a nematode. What is it? What's it eating? You know, the first thing I ask is, what does it look like it's eating? Well, it looks like it's eating bacteria. Well, guess what? Compare it to a bacteria eating nematode. You got a good guy. So you don't have to be like a 10-year soil biologist. You don't have to be, you don't have to go to school to learn this stuff, especially since there's this little thing called the internet. And in this day and age, I can take a picture of microbe. I'm giving you all secrets here. I can take a picture of microbe with my microscope. Then I go right to Google using Google Lens, and boom, it tells me what it is. And, more often than not, it's pretty close. It will get me into the class. It gets a little tricky, gets a little funky when you're talking about some of the fungi and things like that, because sometimes you need better than just a little tiny picture for them. It's helpful to find spores and things like that to help improve your ability to identify with them. But on the whole, we don't really need to identify them. I don't need to say this is Fusarium. I don't need to say, this is again lactic acid bacteria. I don't need to say this is E. coli. I just need to know how diverse my soil sets are. I'm after diversity. See, the more diversity I can find, the better off my soils are going to be. The more improved the function of the soil nutrient transfer. The rhizophagy cycle doesn't work without bacteria. It works poorly without fungi. We can talk about other ways of fixing nitrogen plants, rhizobia bacteria and legumes and other plants. We know we need them. This is another form of bacteria. And if it's not around your legume roots, you're not fixing nitrogen, regardless of how many times you read that legumes fix nitrogen. Without this particular organism, it's not happening. So microbes, they're all around us. They're under our feet. It's good for us to enjoy them. It's good for us to get a lot of them near our plants. It's good for our seeds to have them on it. You know what I mean? The life on the seed is largely impacted by the microbes that are on the seed and contained within its husk. Those are the first microbes to go to work when that plant starts to germinate, when that seed starts to pop life. Those are the first forms of functional soil biology that are going to transfer nutrients and immunity protection to that plant as it evolves. So when you obtain seeds that have been sterilized, or worse, they were sterilized and then they were introduced to a toxin, a seed toxin or a plant toxin, things get dicey really, really quick. Plant enough of those, and that's the way to turn part of your garden into a nightmare. So, I can't say enough wonderful things about aerobes, but I also like anaerobes for what I was suggesting before by using them as a fertilizer agent. I didn't believe it at first. I used to think that stuff smelled so bad I can't use it. It's anaerobic. It'll kill my plants. And Master Yang Sang Cho from the Dead End Method was very clear on this. He said, you can put any type of organic matter in it, any type of plant. It doesn't matter if it's a disease or otherwise. It's all going to break down in the end. And when he said it's all going to break down in the end, that was like a light bulb went off in my head, because that's what Paul Gauchi says. It all breaks down in the end. All of the wood chips break down in the end, even the ones that slow grow. So keep that in mind, folks.